So if I want to, here we go. Okay, so when I say solve, can someone raise their hand and remind me what I mean when I say solve? What am I trying to find? What am I trying to do when I use the specific word solve? Find what x equals. And I can't find what x equals until x is all by itself, right? So I need to undo the things by the x. Now in 1a, there's only one thing by the x. It's the squared, right? So to cancel out a squared, I'm going to square root. Now, if I do it to one side, right, I have to do it to the other side. Now, this is where you need to be careful because, all right, if I have x equals 5, right, then the problem is you're telling me that the only number that I can square to get 25 is 5. But that's not necessarily true. There's another one. There's one more number that I can times by itself to get 25. It has to be the same number. That's a good guess, but it has to be the same number. Not another 5. What happens when I have two negatives, my friends? So not only can I have a positive 5, but I also have to have a negative 5. The plus or minus thing, that's indicating that I need to have both a positive and a negative of the number. Okay? Every time. Okay, now let's go ahead and, yeah, Gavin. Sure. Let's talk about why we need the negative. Because if I want, okay, if I'm trying to solve this equation here, I am trying to find any x that makes this true. Well, if I had 5 squared, then that would equal 25, right? But if I also have negative 5 squared, because two negatives make a positive, that also equals 25. So if I'm supposed to solve for x, I need to find any x that makes this equation true, so it has to be both the positive and the negative. Does that help? Okay. Anyone else? Okay. So now, that one was kind of easier, right? Because the 25 was a perfect square. Okay. Let's try this next one. If I square root both sides, I have x equals the square root of 28. Not a perfect square. Okay, Bryce, can you get your notes out? Thank you. Not a perfect square. But lucky for us, we spent all of Unit 2 learning how to deal with square roots that aren't perfect squares.
You leave them.
No, you don't leave them.
Isn't that the test that we bombed?
Yeah, and then you took a second time, and then you got it great. Factor trees, my friends. Factor trees. Tell me two numbers that multiply to 28. You guys, this is an easy lesson. We should get through it quickly. I need you to focus. Thank you. 7 and 4. Does it go down any further? Then I circle my pairs. So x is going to equal 2 root 7 and negative 2 root 7. What do you mean fix the negative?
That's only if it's in the
No, you can write the plus or minus. The reason why, hey guys, listen. You can write the plus or minus, but the reason why I'm always going to write them out like on this is because when you guys type your answers into the Canvas quizzes, they don't have a plus or minus symbol. So you have to always write both answers on Canvas, okay? So that's why I'm always going to write them out, okay? All right, next one. What do I do to get the x alone? Okay. X equals? Nope. Nope.
What? Isn't like 3i or something?
Hudson for the win. 3i, the square root of a negative number. 3i and negative 3i.
So that's what I was trying to ask. I was like, when it's negative
Well, the negative is under the square root when it's an imaginary number.
So wait, why is it -3i if you're already making it from
Well, but the two negatives are a different thing. Because this -3, when it's squared, will be 9.
okay, so I guess
And then I squared, remember, is -1. So this -3i squared is going to be -9. Okay? So why is the plus or minus needed? Because when you square a negative, it becomes positive. So that is why. Now, on 2a, we're not ready to square root yet, right? Remember, solving is all about getting x alone. So when you do your order of operations to solve, you're undoing things, you kind of got to do the opposite of PEMDAS. So in Please Excuse My Dear Aunt Sally, we would do exponents first, but if I'm trying to undo stuff, exponents has to be the last thing that I undo. Michael?
So would you divide 5?
Yep, good job. So I'm going to start by dividing by 5. Get your calculators out if you can't do that in your head. I need to know what 125 over 5 is. It is 25.
25
And then I square root, and x equals 5 and -5. Okay, do I need to do anything on b before I square root? Nope, okay. Is square root of 12 a perfect square? So that means I'm ready to factor tree. Which one is going to go in the radical, the 2 or the 3? The 3, the one without the pair. Good. So x equals 2 root 3 and -2 root 3. Okay, am I ready to... Okay, let's stop here. Is there any questions? No? Okay, am I ready to square root on C? Divide both sides by 4 first. Good. So x squared equals what? -1. Now I can square root both sides. How does the square root of -1 simplify? I. Good. So x equals I and -I. Okay, big ideas of solving by square roots. Okay. Wait a minute. Big idea of solving using square roots is that, get everything I should say get rid of everything. Get rid, okay, let me try this again. Get rid of everything except the square. What about my A's? First. Then the other big idea is don't forget the plus and minus. Good? Okay, so last part of today's lesson is talking about, okay, is there any questions so far? Anybody? No? Okay. The other part of today's lesson is we're going to talk about the fundamental theorem of algebra. I kind of prefaced this last time a little bit. Okay, so first of all, can someone raise their hand and remind me what a complex number is? Hold on one second, pause.